Hello, beautiful people. Future me. I'm here. You are here. That means, you know what it means. It means it's time for another programming workout, and we will start with a typing practice at every single time, and we will go from there. Next lesson, and go. Okay. Oh, that is not dash. That is dot. Okay. What the hell is this anyway? Ah, doesn't matter. Opening. Opening. Okay. I don't. Uh, this, that, that. All right, 3 minutes, 3 minutes. So maybe I can do another one. What is the error? 4%. Well, good, good. That's. I remember I started at something like 10 or 15 even. Oh, that's good. Hash here. Good. Ah, ha, ha. This is more difficult. So many special characters. Oh, it's good exercise for me. It's good. Ah. All right. That's almost double the time I was planning to, but hey. 6%, 36 BPM. Almost 6 minutes I was doing this exercise. There was a lot of special characters and like these devilish combinations. So it was good exercise for me. Good, good. Keep them coming. Keep them coming. So what we will do next? We will do next some. I can do maybe continue in this one, and I already know there are 3 categories which I can pick from, or they are available to me right now. So I will randomly choose the topic I will be working on in the next 20 minutes or so. And it's SQL. I can see already. Excuse me. All right. So SQL it is. Congratulations, sir. You are the winner. So, in this course, the exec. Okay, so now they are this repetition. It's kind of like exercise. What I have learned, this is probably something I was making mistakes in. So, first we are creating a table with people in it. Well, no, a table called people. 2 columns, ID and name, integer primary key, and text not null. Then we have a cat with a similar structure, 2 fields, owner ID and name, and then we are inserting Amir 100 and the cat that is Mrs. Fluff. Then Betty has a Kinu cat. Okay, now This is creation of the database and filling it in. And then we are selecting a name from cats where owner ID is equal to 100. 100 is Amir and owner ID is 100 for Mrs. Fluff. So we will get back an array as always and one object in it. We were selecting name. So that is what we will get. It says Mrs. Fluff. And that should be correct. And it is. Good for me. Next example. In the first execution, the SQL statement, SQL script, SQL query is the word I'm looking for. We are creating table, people and cats. That's the same thing we saw moments ago. Then we have a people, we insert in it Emir, and then we have a cat, and we insert into it Mrs. Fluff. So, then we have a function, and we are finding a person's name. Then we are running a query, which will return us array, and we are selecting ID. So that has an ID, people. Then for each of the fields in people array, we will select a person. Then we are using that person.id, the field on a person, to select a name from cats where we've got the ID. So now we are pushing all cat names, push cat.name, not the entire object, just that. And we will return all cat names. So this I remember, I did this. And that was bad because that's not what we are returning. We are returning just the cat name in an array, and the name is Mrs. Fluff. And this should be correct, and it is. Hooray for me. Okay, so now we have another thing, free thing, so it might be in here even somewhere. Yeah, bam. First we are doing. So comparing with no, let's go. Is it loading? Oh, now there is it. SQL comparing with null on all of these chapters or fields or places, whatever. Null in SQL database has some sharp edges. Oh, does it? For example, mathematical operations on null give another null, which comes back to us as JavaScript's null. Okay, so select null plus 0 as result is null. Okay, select null plus 1 as a result, that will be also null. So we will get the object that will say result, and here will be null. Go. Okay, so here's multiplication. That will be exactly the same thing. So it's more like typing exercise for me right now. When we use equal to compare anything with null, we get another null. That's even true when comparing null equal null. Oh, wow. That is unexpected behavior. It's just weird. Okay. So we will get result, and that will be null. Then we select null equals 1 as a result, so anything compared to result is anything compared to null is a null, so this will be a result. It's null. And there's a cut. Yeah, well, it will be the same, would it be? So, bum 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 bum. What is the difference in here? Well, the only difference in here is like they shifted the null from the left side of the comparison operator to the right. So another typing exercise, I think. Go. Okay, so we are past that. Now to the next thing. Fortunately, SQL also has is null and is not null comparisons. Comparisons? I mean, like, now I want to know how it is pronounced. Yeah, and I wanted to do translate because that speaks to me literally. Comparisons. Comparisons. All right. So that properly check for null values. As usual, SQLite uses 1 and 0 to represent true and false. Okay, null is null as a result, gives us 1. Select null is not null as a result, that will be 0. Okay, so result will be 0 because SQLite does not have a boolean, it uses 0 and 1. And select 5 is null, so this will be a result. That is false, so like that. It's not null, it will be true, so result will be true, and SQLite is 1. And select null equal null is null as a result. Okay, so now I'm thinking this will be executed first. So null equals null will give us null. And then it says is null as a result. So it is a true. So a result in this case I think will be 1 because SQLite does not have a boolean. Usually you'll see is null and is not null as conditions in where queries. Show me. Oh, you don't. For example, suppose that we have a database where only some users have emails. We want to email all of users. To do that, we need to select all users who have an email address. Do we? I would select only the emails. So, we are creating a table, text.null, email text can be null. So then we are inserting two guys, Amir and Cindy, and one Amir has the email, but Cindy does not. Weird in this day and age. And now we will select everything from users where email is not null. Okay, so this we will result. Our result will be an array, and in there we are selecting everything. So that means name. And the first thing found with email not null is Amir, and then email is Amir at example.com. And Cindy, bad luck, bad luck. Oh, here we go. Typo. Okay, name Amir, email Amir at example.com because typos are my nemesis. Typo is my nemesis. Typos, my nemesis. Oh, Here's, anyway, this is correct. Everything so far is correct. You see how great I am? This is the awesomeness meter. Here's a table where some users have a cat and some don't. Select all users that have a cat. Alright, so select everything from users, where uh, uh, cat name not null, like so. I think it's not null. Is not null is the entire operator. Is not null. Okay, is not null. Alrighty. Okay, so it should do that. Typo, where you are. I don't see you, so I'm pressing the button. And here we go. The specific details of null handling vary from database to database. Fortunately, SQLite's null behavior was designed to be similar to another SQL databases, so the specifics above apply to most databases. And that's it. Oh, you will be missed. Alright, two things to choose from. SQL injection and foreign keys. So I will use that, but we won't select only from two, and the two it is. So foreign keys. Oh gosh, this is long. All right. One big selling point of SQL databases is correctness. The database lets you set up constraints that should never be violated. Then it makes sure that we don't accidentally violate them. All right. We can't insert into columns that don't exist. We can't insert or update nulls into not null columns. Okay. We can't insert or update duplicate values in unique columns. In most databases, we can't insert the wrong data type into columns. SQLite is an anomaly here. Yep. Yeah, I know. I know, and it is dreadful. We've seen tables referencing other tables, like a cat's owner ID referencing to person's ID. What if we make a mistake with those IDs? What if we insert a cat whose owner ID doesn't reference to any actual person? So far, we haven't seen a way to prevent that. Remember that statements like create and insert return an empty array. Okay, I do return an array. What is an empty array? Why is it empty array? Did does it seems to like the right or closing square bracket is a little bit higher than the opening? Or is it only me? It seems to me. I don't know. Create table. So we are creating table. We have a ID and name. This is the primary key and this is not null. Then we are inserting name into people mirror. Okay, so this ID will be 1. And then we will create a table cats on our ID and name. And we will insert into them. Okay, so this will output this. And now we will select ID from people. So this will give us this, and the ID will be 1, I believe. Yep. And then we will select owner ID from cats where name is Mrs. Fluff. If I remember correctly, that is the... Isn't that the name of the new cyberpunk thing? Where Keanu Reeves plays? Uh, Punk. No, that's different one. Okay. Anyway, so this one will give us owner ID, and it will be equal to 2170. Oh, to 2170. I'll close it, and we are correct. Now we will select a name from people where ID is that, and we will get this because there's nothing like that in our table. This is a problem. The cat has an owner ID, but there's no person with that ID. Suppose that this database is being used by a cat groomer. Mrs. Fluff is dropped off and gets our grooming, looks great, and the database says that the owner is person who doesn't exist. Who do we call to pick her up? We have one extra cat, no problem. The database is wrong. Cats are supposed to have owners who actually exist. We can prevent this mistake with a foreign key, a column whose value must equal a value in another table. In our case, we want database to ensure that every cat's owner ID equals to some person's ID. Note the new references syntax in the cats table below. So, okay, so it is reference. I don't know how to pronounce it. I'm sorry. Hanging there. Yeah. References. References. Okay. References. People ID. Name text not null. My head hurts. Not because of that, because I'm cold, probably, or something. I don't know. So this will return that. And the database won't let us violate this foreign key in any way. Show me. We can then insert a cat whose owner ID referenced a person ID that doesn't exist. We can change an existing cat's owner ID to one that doesn't match some person. If some cats reference a person, then we can change the person's ID. Oh, that would leave the cats referencing a person ID that doesn't exist. Yes, sir. For the same reason, we can't delete a person referenced by some cats. All right. All of the following examples use the two tables above, each example is separate, and each starts with the tables empty. Remember that you can type error to indicate an error. All right. So, insert, 100 Amir, 100 Mr. Fluff. Good. Now, insert into blah, 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 values. So this is an error. There's a no, this is okay because we still did the reference thingy, right? So this is okay. No, it's not. How come? Oh, yeah, because here we are inserting and we are already using those tables over there. They said that, right? So this is error. Good. Now we are inserting people. So there's a again. Okay, so it should be like somehow separated, but I understand. This was one example and there is a second one. Amir, Mrs. Fluff, and then updates at people one na. Our cat will be an orphan. So error. What if we do want to change the ID? Is there a way in this scenario? That's what I'm asking. Okay, so now we are what? Now we are inserting. So this is another example in my opinion. We are inserting a mirror, Mrs. Fluff, and then cat set owner ID. Yeah, and this is error as well because 101 is not anywhere to be found. So error, and I know how I would do the moving of the ID. I would create a dummy user, then move all the cats which belong to the user which I want the ID to be changed to be owned by the dummy user. Then I will change the user I want to change, the ID, and then I will move all the cats from the dummy user back to the back to the desired owner. Is there an easier way? I don't know. Anyway, so now we are inserting Betty. Hello, Betty. Haven't seen you for a while. And cats Xkinu. Okay, so delete from people where name is Betty. Now this is an error, my dear, because our Kinu would not have owner. So people Betty, Kinu, and cats. And then we will delete cats where Kinu, yeah, that we can do. And then we delete from there, yeah, and that will let us do that because we would not be coupled anymore. All of this safety comes from that one little references in our table whatever. In our table definition, this shows us the power of SQL's declarative constraints. Power. We don't have to write separate code to say a person can't be deleted if they still have a cat. A cat can be updated to have an owner ID who doesn't exist, etc. That one little foreign key clause prevents many kinds of mistakes. That was references, right? Okay. We references. Okay, I will probably misspell that in the future. We have a nice phrase that describes preventing all of those mistakes. Referential integrity. Referential integrity. Referential as in concerning references from one table to another, and integrity as in the references are guaranteed to be correct. Create a cats table with a text name and owner ID integer, foreign key that references the ID column of the people table. All right. So, oh, I double clicked or what? No. Okay, so create table cats with name that is a text. Then we have a owner ID that is an integer. And then, oh, this one is reference. Ah, this looks good to me. And it is people and ID. And that looks good to me. Let's try. Yay! I did it. We are still allowed to update and delete rows in any way that satisfies the foreign key constraint. For example, we can update Kinu's owner ID to reference Amir instead of Betty. The Betty can be deleted because no cats reference her anymore. You can update Kinu's owner ID to reference Amir instead of Betty. Yeah. Plum plum plum, and that is what it does. Okay, so Fluff belongs to user 100. That is Amir. Fluff, then Betty. Okay, then Kinu is now owned by Amir, and then we will delete Betty, and we will select name, owner ID from cats. So a little bit of typing. So name will be Mrs. Fluff first, and the owner ID is 100, like so. And our second cat, Kinu, name Kinu, now has a new owner. Owner ID will be 102. Bet it was 200, right? Yeah. Run, and I'm correct. The foreign keys were respected at every step of that change. Initially, both cats owner IDs reference different people. We update Kinu's owner ID to be 100, which is Amir's ID. Now both cats are owned by Amir. When we delete Betty, then we delete Betty, which is okay because no cats reference her anymore. Setting up these constraints takes effort. It's more work than throwing all of our data into a schemaless database with no foreign keys. However, we do this work because it saves us from other work that is more annoying, more difficult, and more error prone. Carefully creating a schema now means that we are less likely to end up with invalid data in our production database. Our foreign key means that we'll never find orphaned cats whose owner ID reference an owner who does not exist. If PostgreSQL ever allows us to orphan a cat, that's a bug in PostgreSQL. You may also hear people talk about leaked records by analog to memory leaks. That means the same thing as orphaned, a row that's referencing to another row that no longer exists because we didn't add a foreign key constraint. Hmm. Really? Does it really mean that? The same thing as orphaned? Not sold on that one. Finally, a note about terminology. Why are these called foreign keys? A key is a column that uniquely identifies a row. We've seen several tables with numeric key called ID, but we could have other types of keys. For example, users tables often have an email column that's a key. No two users ever have the same email. Uniquely, okay. A cat's owner ID references the person's ID key. From the cat's perspective, owner ID is referencing something foreign. The ID column of the people table, that's why it's a foreign key. Yep. And that's it, and we are finished with this lesson. Congratulations me. And they say I will be in about 6 days. Don't trust it because I might not do the exercise. Anyway, we are 10 minutes after over the time limit we set up for ourselves, so that means we are done, and done is better than perfect. So have a wonderful day, beautiful people.